Hello everyone. So we are here again with a new video with a new problem. So I'm sorry for the delay of this video because there is some health issue. That's why I can't make video for that problem. And that problem is a little bit tricky and hard, we can say, to understand. So now let's start this video and try to understand. Okay. So for the problem, there is a lot of description. Let me try to explain you this problem with the help of this first test case. So it is given in the problem that we have a given graph, and the graph is actually a bidirectional weighted graph. What do you mean by a bidirectional weighted graph? It actually means that we have a given graph as you can see there, and between two nodes there is an edge, and to move from one, let me change the color. Wait, okay. So to move from this node to this node, we have some cost. Okay. Similarly, to move from 0 to 2, we have some cost. To move from 2 to 1, we have some cost. And whatever the cost from 0 to 1 is same as the cost from 1 to 0. So as you can see, these are the nodes, 0 and 1 are the nodes, and the cost is 10. Similarly, 0 to 2 is a node, and the cost is 1. Similarly, 1 to 2 is a node, and the cost is 2. So what is the problem? The problem is we are at this first 0th node, okay, and whatever the cost in between the two nodes, we have to imagine that if there is the 10 cost, so we have to imagine there are 10 intermediate nodes present between 0 to 1, okay. Similarly, in 0 to 1, 2, between 0 to 2, we have a 1 as a cost, so we consider 1 as our node. Similarly, from 2 to 1, we have a 2 as a cost, so we have a 2 node. So what is actually the problem? Now, the problem is we have to calculate that if we are at this 0th node, or we can say the first node we have to tell that how many nodes can be occupied, or we can say can be traversed if we have some condition. Now what is that some condition? The condition is from this 0 to any direction, okay, understand this, from this 0 to any direction we can only take up maximum moves of 6. So if we are at this, you can take this 1, this 2, this 3, this 4, this 5 and this 6. So these are the 6 moves. So this is the one direction the 0 is connected with. As you know, the 0 is connected with 1 and the 0 is connected with 2. So this is the first thing that we can from 0 to 1 we can use or utilize our 6 moves. Now from 0 to 2 we actually have only one node here. So we also have to consider cell as well. So if we come to this and if we come to this, so from the total 6 moves we traveled the 2 from 0 to 2, right? And the remaining is 4. It actually means whatever the remaining moves we have, we can also explore from that node if and only if we have consecutive or we have some edges to explore. So you can see from 2 to 1, which we can say the 0 is connected with 1 via 2. So the 0 is connected with 1 via 2. So if from 0 to 2 the maximum moves we take 2, so the remaining moves is 4. So we can explore this 2 because this one is not explored till now. So one more thing we can grab from this, that at a time we can only visit a node once. Okay, we can't visit a node again and again. So we can do it from 2 to 1 and we explore these 3 nodes. So here we have 1 is remaining there. Now these are all the intermediate nodes and we only visited this node, but from 1 to this side we have nodes again as well. So we can also go through this. Okay, and the total is 6 is there, 6 is there, and the 0 itself is 1 here. So 6, 6, 12, and 0 itself is 1, which is 13. So the 13 is the output here. The problem is easy to understand, but difficult to code. But I will try my best to understand it. Okay, to tell you how we can approach it. So from this you can see one important thing there. And what is that important thing? You can see from each node what we are trying to do. We are trying to traverse its neighboring nodes. If we are at 0, we are trying to traverse 0 to 1 or 0 to 2. But if let's suppose from one node to another node, if from one node to another node, we have less nodes within that. So we can say we can move from there to there, and after reaching to that node, we also remains with some more nodes, that some more moves that we can use to explore more from that node. Okay. So here we can see that we have to find some shortest path, some stuff like that. And for that, a very popular algorithm of graphs, which is a discussed algorithm, is used to implement it. So I want to explore about a discussed algorithm for you so that we can understand this problem very clearly. So this is the note made by me regarding to discussed algorithm. Okay. So what I am writing, let's try to understand from that. So I am writing that the discussed algorithm have a concept of distance. So what actually we did in the discussed algorithm, whatever the position we are in, we have to calculate the minimum distance or minimum distance required to traverse each node. So we have to find the minimum distance here. So we are using the concept of distance here, and how that works. See, for the detailed explanation, if you want, you can comment in the below section and I will create a dedicated video for that. But for now, I will tell you how we can proceed for this. So we are at the first node, and for the remaining nodes, we don't know how much distance, okay, we just need. So for that, you can see there is a max, or infinity we can say. So for the remaining nodes, we can say the maximum distance to reach from 0 to there is infinity, because at that point we don't calculate it. But we are present at 0. Sorry. So we can say that the 0 for the 0 we should not have to cover any distance. It is 0 because we are at 0. Now the algorithm works like, whatever the vertex or whatever the nodes which is connected with this 0 node, we see it. Okay, so we can see 0 to 1, there is a cost of 1, from 0 to 5 there is a cost of 6, right? So what the concept is, we only explore, we only try to take only those nodes having a less distance. So you can see the one node has a less distance of 1, and what we do, we check if we reach to 1 through 0. Okay, so what is the distance we require? So till 0 we have to cover 0 distance. So if we cover distance from 0 to 1, it is 0 plus 1, which is 1. And before that we have a mixture, which is an infinite value. So we can say that we can say that the 1 is the minimum distance. So we update this to 1, right? We update this to 1. And for the, as you can see, 0 to 5, we have a distance of 6. Okay, so we can update this as well. Now we are reaching at 1, and the 1 is visited, and the remaining node which is not visited till now is 2, 3, 4, 5. So again, from 1 to 2, we have to cover 1 plus 2 is 3, and the previous one is match. So the infinity value is very much high, so we change it. Similarly, for 2 to 3, which is 3 plus 3, which is 6, and previously we have infinite. Similarly, 6 to 4, which is 6 plus 4, which is 10, so we update it. Okay, let me just, okay, now it is fine. Similar thing happens there. Now you can see it there. If we try to cover from 0 to 5, so the 0 to 4, the distance is 10, and from 4 to 5, the 10 plus 5 is 15. But you can see we have 6 at this position. Then we can say that we don't need to traverse or to reach 5. We don't need to traverse through this long way. We can traverse through this. Okay, that's why we don't update it, and it's remain 6. And that's how we are using the discrete algorithm. Please wait, actually there is some issue. Let me pause this video. Okay, actually my mouse cell is getting low, so I have to replace it. Okay, so I think this part is clear to you. Now let's come to the next thing. So there is a restriction. What is the restriction? As you see here, we have to traverse each node, right? We have to traverse each node, and we have to traverse in the minimum distance. But here we can't traverse as it is, because there is a restriction of one thing, and that thing is the maximum moves we can take. So here is a thing which is a maximum moves. We have to understand how we have to deal with. And the next thing is how to store where we are and how much we can explore more. What is that thing? Understand it. So see, now we have to come to this part. So see this part. Let's suppose from let's suppose from this 0 to this one, we explore that much part, right? Now we try to explore from there to there, and you know, from 0 to 2 is connected, we can only access 2 from 0, not 1, not like that. Okay, so we can say that from this to this we use some moves that we have, and we have some remaining moves. And now in previously we always start exploring from this 0, but now when we reach there, Here the exploring node is 2 and the remaining node is 4. Understand what I am saying? That 0 to 1. Okay. There is a lot of nodes such that all that moves is used directly. Okay. But from 0 to this one, 0 to 2, we can't use our moves. So from 0, we can only explore 2, but we have remaining nodes which is 4. And for further exploration, we need 2. So how we can store this? Like how much moves we have now? What is the next exploring nodes we can use? So we have to take care of all these things. Okay. So actually, I think we have to come up with the code part. Okay, because from there you can understand it in much better way. I think. Okay, if you get the discussed algorithm, what we did in the discussed algorithm, we simply present at some node and we try to access some other node through some node, and we check that if we access this node from, let's suppose, a zeroth node or whatever the intermediate node present in it, so the distance to this, if this distance is minimum and the another distance is maximum, we simply update the minimum distance, right? So we can use that concept actually. Okay, this is actually difficult to understand, but yeah, the problem is formulated in that way. Okay, so this is the code. So we are using the default dict because here we are storing, like we are simply storing node and its neighboring node and what is the weight, or we can say what is the weight we have within 2. So the similar thing, we are creating a graph, then we iterate all the edges. I is, let's suppose, the node, j is the neighboring node, and w is the weight between 2. So we are adding I to j because this is an undirected graph. It means from this node to this node there is a distance, and this node to this node there is also a distance. And one more thing, as you can see in the above example, we have 0 and 2, and within that we have 10. So if we are exploring the 10 nodes, so we have remaining 4 nodes, we also have to store it. Okay, because when we come from 1 to 2, we come to know that for this 2 we have remaining 4 nodes to be explored that we can, so we can use that information there. Now the thing I am telling you, that where we store, like if we traverse from 0 to 2, now at that point the nodes or the distance we have, see the node is 2 and the distance remaining to be explored, so we have to save it, whatever is the maximum moves we have. That's why we are using heaps for that. Okay, and initially we are present at the 0th node and the distance is 0. What is that thing? As you see in the discussed algorithm, for the 0th node the distance should be 0, so that is the thing you can see from there. Okay, so we are at the 0 distance, 0th node having 0 distance. And what is that infinity you are saying? What INF is the infinity value for all the remaining things. What is that? Simple stuff. As you know, we assign maximum infinite value to all, because as in the starting we don't know what is the minimum distance or what is the distance requiring for that. But for the zeroth, we make it initialization to be 0. As you can see, we make all to be infinite, but this 0 and starting to be 0. The same thing happens there. What we mean by original nodes? So what we actually try to do, simple, the original graph is this. The original graph is this one. And first we try to apply the Discrete algorithm on that, and figure out the distance, or figure out how much distance, or how much distance we use to move from there to there, there to there, and there to there. And then we work on this intermediate nodes. Okay, I think that much part is clear. So uh, while heap, it means something present in the heap. So we are at the zeroth distance, sorry, like the distance for the zeroth node is 0, and whatever connected with this, we are exploring its neighbor. So this is the neighbor, and this is the weight associated with each neighbor. Okay, that is, I think, fine. Now now we are calculating the distance. This is what, this we can say, this is a via distance. What is, what we mean by via distance? See the discussed algorithm. As you can see, from 0 to 5 we have 6, and from 0 via 4 to explore 5 we have 10 plus 5 15. So this is a via distance. Okay, and that much part is the via distance. So we are saying from the node we are exploring from, if we exploring the another node using this neighbor, okay, so this is the distance required. But similarly, if the present distance of this neighbor, which is already present, if that one is greater, and if the via distance is smaller, so we have to update it. Understand it? And similarly, we have to explore after that. Why? Because from there, this to this node, we use some moves, and we have remaining, we have some more moves to explore. That's why we push into the heap, so that we again pop that remaining moves and explore it. Okay, that much part is clear. Now what is this, sorry, what is this answer? Okay, so the answer is a very simple thing. What we are doing, we are calculating all the distance needed, okay, from one node to another node. Okay, like in that part, for each big nodes, we calculate from there to there how much distance should be needed, from there to there how much distance should be needed, from there to there how much distance should be needed. Now m is the maximum moves we can take. Now from this node to this node, if the distance we calculated is less than or equal to the maximum moves we can take, so we can say that all this can be explored. Okay, let me give an example. Let's suppose there is a node and there is another node, and from there to there, let's suppose there is a requirement of 5. From there to there we needed 5 cost. Okay, and the 6 is the maximum move. So we calculated this 5 distance from here, and if for any node the distance of I means for any node, if the maximum move is greater than or equal to that, we can consider that thing as a part of my answer, right? And in that part, what we did, we simply explore to edges. And what is the thing? This is used for the intermediate part. What do you mean by intermediate part? Simple as that. As you can see, that we calculate that from 0 to 2, we needed 2. We needed only 2 moves, but we are remaining with some moves. Understand that part? Let's suppose we move from 0 to 2, and we know that there is a two part and we consider it in our answer. So till now, till this answer part, we only work for this original nodes. We don't talk about the smaller nodes within that. Now we have to check if there is any remaining moves present at some node. We also have to explore it and increment in our answer. Okay, I think you get it. Okay, so the thing is, from till there we only work for the original graph that we have. After that we are checking at some node. Let's suppose we have two distance for the above example and we have 6 moves. So the remaining moves is 6 minus 4. Sorry, 6 minus 2, which is 4. And if there is some remaining stuff, we have to increment in our answer. Okay. How we can increment? Simple as that. W plus W2 minus the maximum of the remaining moves we have for both the nodes minus W. W tells us the nodes we already explored. Okay, let's suppose we are calculating from 0 to 2. From 0 to 2 we have 2, but we already consumed this 2. That's why we minus it, and whatever the summation of these two we are adding this. So whatever the maximum of these two, if let's suppose it becomes negative in some case, so we take 0. Okay, and in some case if there is no remaining nodes, at that condition the w1 becomes the negative part, because the distance, let's suppose in that part, uh, in that much part we have 10, right? But we can only explore 6. So when we do 6 minus 10, so we have minus 4. It actually signifies that we don't have much other nodes to explore. So that's why at that condition we only add 0 to it, so that it don't make any change to my answer, and at last we return this answer. This problem is very like not easy to understand, but yeah, that is the whole intuition behind this. I hope you understand this. So let me submit this uh, and accept it. Okay, friends. And if you want to understand the algorithms related to graphs, comment below. I will try my best to understand, to teach you. Okay, bye bye.